Okay, we are now taking the chemical name and writing the formula. So, chromium 6 phosphate. When we look on the periodic table, we find that chromium is here. You can't determine the charge of chromium by looking at the periodic table. That's why they gave you the 6 in Roman numerals. So it's Cr with a +6 charge. Phosphate with a polyatomic ion is PO4 with the -3 charge. So we're going to crisscross Cr3 PO4 6. 3 and 6. Those are both divisible by 3. That means we can reduce it. So it becomes Cr PO4 3. Vanadium 4 carbonate. Carbonate is CO3 with a -2 charge. It's a polyatomic ion. When we look on the periodic table, vanadium is right here. You cannot determine the charge of vanadium by looking on the periodic table. That's why the charge is given to you as a Roman numeral. So that V, that 4 there means that the vanadium is a +4 charge. Carbonate is CO3 and it has a -2 charge. We crisscross and it becomes V2 CO3 4. That can then be reduced. The 2 and 4 are both divisible by 2, so it becomes VCO3 2. Number 13. 10 is right here on the periodic table, and notice it does not have a charge on the top. That's because it also changes its charge. That's why they gave it to you as a Roman numeral. So 10 is SN, and that 2 means it's a +2 charge. A nitrite is a polyatomic ion. It's NO2 with a -1. So we're going to crisscross those, and we're going to crisscross them outside the parentheses to be SN1, NO2, 2. Cobalt 3 oxide. Cobalt is right here on the periodic table. That 3 means it's a +3 charge because you can't determine its charge just by looking at the periodic table. Oxygen is right here. Oxide becomes oxide. Oxide is oxygen with a charge. And that's a -2 because of what row it's in. So CO, it's a +3 because of the Roman numeral. Oxide is oxygen with a -2 because of what row it's in. We're going to crisscross it and it becomes CO2O3. Titanium 2 acetate. Titanium is here. That 2 tells us that it's a +2 charge because you can't look at that. You can't look at it on the periodic table and determine its charge. Acetate is the polyatomic ion C2H3O2 with a -1 charge. So titanium has a +2. C2H3O2 has a -1 charge. And crisscross it becomes Ti1 C2H3O2 2. Vanadium. When you look at the periodic table, is right here. You can't determine the charge by looking at the periodic table, which means that's why they give you the Roman numeral, and that's a +5 because the V is 5. Sulfide is sulfur with the charge. It's right here. It's a -2 charge. So V with a +5 and sulfur with a -2. Crisscross, it becomes V2S5. Number 17. Chromium is right here on the periodic table. You can't determine the charge by looking at it. That's why we give you that 3. So that's Cr with a +3 because of the Roman numeral 3. Hydroxide is OH with a -1 charge. That's a polyatomic ion. So we're going to crisscross outside of the parentheses. So Cr1 OH 3. Lithium iodide. Notice that they did not give you a Roman numeral this time. There's no Roman numeral in there. That's because lithium is right here, and you can look at the periodic table and say it's a +1 charge. Iodide is over here, and it's a -1 charge. So lithium is a +1, iodide is a -1. We're going to crisscross it and it becomes Li1, I1, or Li, big I. Almost done. Lead to nitride. Nitride is nitrogen with a charge, and that is right here as a -3 charge. Lead is down here. Notice that there's no charge in that row. That's because those charges change. That's why they had to give you the charge as a Roman numeral. So lead is Pb. That 2 means it's a +2 charge. Nitride is nitrogen with a -3 charge because of what row it's in. Crisscross it, it becomes Pb3 and 2. And finally we have silver bromide. Silver is here on the periodic table. Even though it's in the transition metal area where the charges change, it's one of the two that don't change. Silver is always a +1. Zinc, which is right here, is always a +2. Even though those are in the transition metal areas, they don't change, and so they don't bother writing a Roman numeral there. So silver is a +1. Chromium is right here, and it's a -1. So we crisscross those, and it becomes Ag1 Br1, or just Ag Br. And that is the end of the naming ionic compounds worksheet.